Alright guys, so this one should hopefully be a quick video. I know you just watched the video that Mrs. A posted, so I hope you guys took notes or paid attention to that. I'm just going to go over a little bit of the titration math. So you guys should have learned what a titration was and how you set it up with the burette and Erlenmeyer flasks and everything like that. So now we're going to go through with some calculations. So I just want to start and tell you that on table T in your reference table, as always, is where you can find your formulas. The titration formula, I put it here, but just remember it's always in the reference table for you to go back and look at. So we have MaVa equals MbVb. Our Ma is our molarity of our H plus ions or of our acid, so we always remember what we're looking for. Our Va is volume of acid, so how much acid we either start with or we use depending on which is our titrant or not. Molarity of OH minus Mb, this is the molarity of our base. And Vb, volume of base. Again, that's either how much titrant we used or how much we started with, depending on whether our acid or our base was our titrant. Just a little side note, you can sometimes see the formula referenced as C1V1 equals C2V2. It's the same exact formula as MaVa equals MbVb, just written a little differently. So C1 is your concentration of acid, V1 is your volume of acid, C2 concentration of base, V2 is volume of base. These are the same exact formula, just written out a little bit differently. So let's take a look at our first titration problem. I'm going to take this one from the video. So if you followed along with the video and did it with them, great. If not, I'm going to do it with you guys here. So in the video, it was a titration between sodium hydroxide and hydrochloric acid. And you were starting with 6 molar NaOH. And we wanted to know the molarity of our HCl, right? So we started with 50 milliliters of HCl, and we titrated with 22.5 milliliters of NaOH. So the first thing we need to do is we need to write out this formula just so we know how many moles of everything was used. So we have HCl plus NaOH. So this is a neutralization reaction. So we're always going to end up with water and some kind of salt. In this case, it is sodium chloride. Okay, good. So everybody is 1 to 1 to 1, so we don't have to worry about calculating the moles right now. I'll talk about that later. So if we go back to table T and we write down our formula, MaVa equals MbVb. So what I like to do, the first thing I always do is I take inventory. So somewhere on my paper, I like to write down MaVa, MbVb. This tells me everything that's in the formula, and I'm able to go through the problem and write down what I was given. So molarity of our acid, this is what we're looking for, so that's X. Our volume of our acid, we were told, was 50 milliliters. Our molarity of our base we started with was 6 molar, and our volume we used titration was 22.5 milliliters. So now that I have all of that information, I can plug it into my formula. So I'm going to have X times 50 mils equals 6 molar times 22.5 milliliters. Right, from here, just regular algebra, solve for X. So divide by 50 on this side, divide by 50 on this side, right? And we end up with X equaling 2.7 molar. Very straightforward, very simple, plug and play is how I like to call it. You take the information that you're given, plug it into the formula, and solve across, right? So let's take a look at another simple titration problem before I talk about something that could be a little bit more complicated. So titration number 2. So let's look at this as a word problem. It takes 83 milliliters of a 0.45 molar sodium hydroxide solution to neutralize 235 milliliters of an HCl solution. What is the concentration of HCl? So first thing I'm going to do before anything else is I'm going to write out the reaction. So we have HCl plus NaOH. We just saw this one, so we're going to get water and sodium chloride as our products. Okay, so now let's write down our formula. MA, BA equals MB, VB. Now, inventory. MA, VA, MB, VB. So let's see what we have in our formula, in our word problem. So it takes 83 milliliters of 0.45 molar NaOH. So that's my base, right? Or my OH minus, my hydroxide ion. So volume of the base is 83 milliliters, and the M of the base is 0.45 molar. Good. So now I'm going to continue reading. To neutralize 235 milliliters of HCl. So I have a 235 milliliter of HCl for my acid, and what is the concentration? So my concentration is X. So same exact setup as before. We're going to do X times 235 milliliters equals 0.45 molar times 83 milliliters. Again, we're going to solve this algebraically, move over, cross out, and we end up with 0.16 molar HCl. Again, these are very simple titrations. Just plug and play, read through, pull out the information you're looking for. Remember that this formula is found on table T in your reference table. That's the last page of your reference table. If you guys don't have copies of your reference table for whatever reason, if you just Google New York State Chemistry reference table, it comes up right away. Or I put a copy of the formula in the beginning of this video. So the next thing I'm going to talk about, if you guys don't want to listen to this, you don't have to. This is just a little bit extra if you want to learn a little bit more about titrations. So those were examples of simple titrations where we only had one H plus ion. So there are also more complex titrations that involve what we call polyprotic acid. And this means it has multiple H plus ions, right? So poly, multiple. So H3PO4 is an example of a polyprotic acid. So the formula for this is a little bit similar to just a simple titration. The only difference is now we're taking into account the number of moles from the balanced equation. That's why on those other two problems, I wrote out the equation. When we write out that equation, we're able to see how many moles of acid and base were used based on the reaction that was occurring. So the only difference with the formula is we are including our moles, and those are Na. So N equals the number of moles, so it's the number of moles of acid for Na. So number of moles acid, and Nb is the number of moles of base. So if you guys are interested, watch the next slide where I go through a problem with you. If you are not interested or you don't want to confuse yourself, just pass on through. Do your castle learning, and if you guys have any questions, as always, you know how to reach us. We are also going to be doing a live extra help on Wednesday that we'll talk about more on Tuesday. So if you want more to learn, watch the next slide. All right, so again, this is an extra titration problem, so don't feel like you need to really jot down notes or pay attention to this, but if you would like a little bit of exposure to this, follow along. So we're doing this with a polyprotic acid. So we're going to use sulfuric acid for this one, where we have two hydrogens or two H+. Remember, poly means multiple. So let's read through the word problem. It takes 38 milliliters of 0.75 molar sodium hydroxide to completely neutralize 155 milliliters of a sulfuric acid solution. What is the concentration of sulfuric acid? So from the last slide, I told you that the formula was very similar. So we have our concentration and our volume, and then we're going to have our number of moles equals our concentration of our base times our volume of base divided by our moles of base. So let's write out the reaction here. So we have H2SO4 reacting with sodium hydroxide. And again, we're always going to get water and a salt. This time we have sodium sulfate, right? So looking at this, I can already tell it's not balanced, right? I have two sodiums on the right and one sodium on the left. So I'm going to go quickly through this in balance. We're going to have a 2 here and a 2 here, and now we're all balanced. So those orange numbers are going to come in handy. So let's set this up. So our molarity of our acid is what we're looking for. Our volume of our acid, we were told, is 155 milliliters. And our number of moles of our acid is going to be 1. Notice how there's no coefficient, so therefore it's 1. Our molarity of our base, we were told, is 0.75 molar. Our volume of our base was 38 milliliters. And our number of moles of our base is 2. That's that orange number I put in front of sodium hydroxide. So when we set this all up, let me get a different color. When we set this all up, we have x times 155 divided by 1 equals 0.75 times 38 divided by 2. We cross multiply and we work everybody out, and we end up with 0.75 times 38 over 155 times 2. We calculate this through, and we end up with 0.092 molar H2SO. Oop. Oh my goodness, I don't have enough room there. Hold on a second, guys. Let me just fix this. Molar H2SO4. All right, so again, this is just extra if you guys want to watch along to see what it looks like. Otherwise, we're really just going to be focusing on the simpler titration problems. So again, if you have any questions, you know how to reach us. Otherwise, get working on your Castle learning and prepare for Wednesday, where we're going to hold a live extra help and post our final assessment for our acid and bases unit. All right, guys, keep up the good work.